Hello everyone, my name is Calum Ritchie and I'm part of the British Geological Survey, where one of my areas of focus is around data visualization and the creation of graphic outputs for our research and mapping. Today we're going to look at a couple of recent projects and the use of interactive PDF for delivery. Firstly, we're going to look at Singapore. The British Geological Survey has been engaged for several years now by the Building and Construction Authority in Singapore to gain a better understanding and map the geology of the island. This research work BGS has performed will aid in future planning. One of the limiting factors in the development of Singapore is the scarcity of land resources. If you imagine something like the entire population of Scotland living on the island of Anglesey, already reclaiming land from the sea has increased the island by over 25% in the last 50 years. The latest round was to take the knowledge gained so far and produce some formal publications. These consist of the interactive geological map, a geological memoir, and a practitioner's guide to the bedrock geology. We're going to look at the interactive map, but before we move on, I'd just like to mention the memoir and practitioner's guide. These work together with the map to tell the full geological story of Singapore. They contain a wealth of geological information and technical illustrations. They are supplied as PDFs but can be easily printed to produce hard copy books and are based on an A4 page size. You can see some double page spreads there to the right. Now, looking at the map, the client wanted an interactive map that contained all the geological themes, provided information on the classifications, and could be printed out. We decided on using interactive PDF, and let me explain why. There are some off-the-shelf map viewers, but generally these can only handle a limited number of non-conflicting layers of information. You could build a map viewer from scratch, but that would take a lot of effort and time to do. PDF allows for a certain amount of customization. It's compact and accessible. There's a free viewer available. Most people already have this installed and know how to use it. You can produce compact documents. The Singapore map file is only 24 megabytes in size. Acrobat also has some useful built-in functionality like the commenting tools, projections, measuring. Now let's have a look at the interactive map that's been built. This shows the main components of the map. There's a title section that contains information on the project along with conditions of use and copyrights. There's the map face layout, obviously. The control palette where you can configure the content of the map and display. And also includes some geological cross-sections. Looking at the map configuration palette, you can see there's a significant number of controls, along with a geological legend. It's been set up so you can only produce proper-looking map displays. There are more than 60 layers of content for the map face, and all this has to be handled correctly to give appropriate map face configurations. On the controls palette, tools are grouped into sections. There's a grouping that contains all the controls for the geological content. There's groupings with tools for the topography, grids, etc. And there's also search, configuration, and printing tools. There's also a geological legend on this panel, which will reconfigure to match the settings of the geological content. Another added feature is the Flyover Labelling, which contains information on the geological classifications and engineering properties. These are available on the map face, with the legend on the map controls palette, and with the geological cross-sections. It provides for direct on-map information when panning and zooming, and removes the need for a large permanent sidebar legend that occupies a lot of the screen area, reducing the map window. Now let's have a demo of the Singapore map. Opening the PDF takes you to the introduction. You'll find information here on the project and the use of the interactive map. Down to the right, you'll find a contents list with links. Select the map view and we're taken to the map face. Next page will take us onto the map display controls. These are all the tools for configuring how the map is displayed. I'll just adjust how the topography is set up. Here's the geological legend. If you roll over the tablets, you'll see there's more information on the geological classifications. Let's reconfigure the geological content so it appears as a superficial deposits only map. And we'll jump back to the map view. Let's window into a smaller area on the map. Let me show you some of the rollover labelling. The map display is currently configured to show the overlying superficial deposits, so the labelling is colour-coded as blue for this. These are showing information on the formations and lithologies of the particular units. I'll change the geological configuration of the map now so it's showing the bedrock and the superficial deposits. Let's also make the hill shading a little bit darker. Back to the map face. The map's been set up to return to the same view, centre and scale. It'll do this even if the Acrobat window's been resized. And these are pop-up labels for the bedrock geology. You've got the intrusive igneous in red and the deposited in green. Back to the display controls and set this up to show the engineering geology properties. You can see this has a considerably different legend. The pop-ups here show information on the weathering strengths and the constituent lithologies of each unit. If you go back to the map controls page, you can find information on the engineering property labels and the infographics they contain. There's also search tools. If I change this to a bedrock map, then I can show the stratotype locations. I can open the palette with the list of all the stratotypes. Select a view scale. Let's go for 1 to 8,000. Select one of the geological units. Let's go for the Kent Ridge member. And we'll be taken to the location on the map. There it is in borehole 1F9. There's a coordinate search as well. Again, select a scale. Type in the desired coordinates. And click on the Go To button. And the location will be centered in the map view at the selected view scale. And finally, there's a set of pre-configured views you can select from. This is in the form of 2 pull-down lists. One covers all the geological features. The other deals with all the other map components. Selecting from these will change all the map configuration controls and the map display. I'll just zoom out a bit on the view. One of the features that makes this map viewer unique is its extensive printing facilities. When you print the map with geological content displayed, a completed marginalia is added to the output print that reflects what geological content has been selected. Outputs are fully finished and to a high cartographic quality. The map is designed to be printed at a 1 to 50,000 scale and requires an A0 paper size. Using the print tool will configure output settings, add the marginalia, then open the standard Acrobat print window. Another printing feature is Quick Print mode. The map uses a lot of transparency blending, which can be time-consuming to process for printing. Quick Print mode will produce a faster output by not using these, but it will be of a lesser appearance. As you will have seen, the map display can be configured in a multitude of different ways. This is then reflected when printing out the map. Obviously, some of the differences will be quite subtle, but it's therefore possible to print a vast array of different map versions. If you work out all the combinations for the maps just containing geological content, it comes to 76,800 different map combinations. The idea behind the map is the user can select whichever version of the map they want to print from the options available. The client has subsequently come back to us and asked us to produce a box set of printed maps. This box set contains 4 folded maps with selected versions that contain the major geological themes. We're going to look at a second project now, which again uses PDF to deliver the output, but this time it makes use of the fact that Acrobat can handle 3-dimensional data. These are a set of regional geological visualization block models, covering all of England, Wales and Northern Ireland, with Scotland currently in production. This shows which regions are currently available and gives a list of their titles. The regional block models are constructed from national geological datasets with some additional new material. They include the UK3D fence diagram, which is a network of geological cross-sections covering the UK, as well as DigMap GB surface datasets. As these are large national coverage datasets, they have been split down into regions and then further divided into subblocks to produce accessible 3D models that can be easily distributed. Borehole records and surface mapping are used to form a geological interpretation in constructing cross-sections. Geological cross-sections are one of the key components used in the construction of full 3-dimensional geological models, and geologists have been producing cross-sections in this country for over a century to better understand the subsurface. 3D geological modelling deals with internal volumes rather than just surfaces, making it one of the true forms of 3-dimensional mapping. It's a complex process, as to produce an accurate interpretation you need to fully understand how the geology formed, as well as the processes that have shaped it through time. Having talked about full 3D geological modelling, these regional GV models aren't in that form, although 3D PDF has been used as a delivery method for these as well, for example, for Singapore. Full 3D models do exist for some selected areas, but it would take a lot of resources to cover all of the UK with a high level of detail. However, these regional GV model PDFs do provide a lot of useful subsurface information in a really accessible form. All 15 of the currently available geological visualization PDFs have a similar layout. There's an introduction that explains the geological data and its use, the 3D annotation view, details on the geological classifications and timescale, and details on how to use controls. Alongside the 3D window, palettes have been added that contain a range of display controls and model tools. These added tools relate directly to the geological content of each individual regional GV model. They allow the user to further explore the geology by dismantling sections of the model and accessing further information on the geological features. You can see here all the controls available in the side palettes. Now let's have another demo. We're going to look at the Northern England GV model. I'll go straight into the 3D view. And as you can see, you can rotate, pan and zoom on the 3D model. There's a readout of the view orientation to the bottom right. I can adjust the vertical exaggeration. As this covers a large area, it comes in by default with a 5 times vertical exaggeration. Each region is divided up into sub-blocks, and you can control which of these blocks is displayed. You can control the display of the surface features, national grid lines, the topography, and the geological surface layer. There's an extensive number of geological units in the model, and no way you can identify these based on colour alone. So by selecting a geological unit, further information is provided on the bottom bar. Also, if you have online access, clicking on the link will open up the BGS lexicon with full information on the geological unit. You can also select the boreholes, giving you further information on these. You can also then access the online borehole records. I'll just finish up by restoring this back to the initial view. In conclusion, this has just been a brief look at 2 recent projects which have used interactive PDF to deliver visualizations of the mapping. Thank you.